Welcome to the deep dive. If you thought the future of warfare meant, slightly bigger tanks and faster planes, well, you might need to adjust your expectations immediately.
Yeah, the collection of sources we've pulled together today, it isn't really about incremental upgrades. It's talking about a full paradigm shift.
A hard transition, really.
Yeah.
From what felt like military science fiction to current deployed operational reality.
Absolutely. We are looking at a complete redefinition of global power dynamics, and it seems to be driven by three core concepts: total autonomy, radical stealth, and a really aggressive reliance on artificial intelligence.
Okay, so our objective today is to unpack China's ambitious new military arsenal. We're focusing specifically on how AI isn't just like assisting, but seems to be actively replacing human decision makers across air, ground, and sea.
Right. The mission is to synthesize the information we have, detailing everything from, well, truly invisible stealth drones and ground combat robots.
To advanced armor, laser weapons that cost almost nothing to fire.
Exactly. And maybe most critically, a dedicated AI commander, one capable of formulating lethal tactics in like milliseconds.
We are going to show you how the sources suggest that the fundamental role of the soldier, and even the commander, is being changed forever, basically replacing human vulnerability with tireless hyper-efficiency.
And this seems to represent more than just a technological edge, It feels like a fundamental strategic philosophy, one that views human limitations, things like fatigue, emotional pressure, the need for accountability, as the primary weakness to be engineered out of conflict.
Oh.
What really stands out immediately, and what you need to understand, is the sheer scale and speed of deployment. The majority of the systems we're about to discuss, they're not prototypes sitting in some dusty lab. Many are apparently already operational, strategically deployed.
That context is vital. This is happening right now. Okay, let's unpack this then. And maybe start, 25,000 meters above the battlefield, in the skies.
Sounds good.
Air dominance has traditionally been about speed, heavy firepower. But these sources show a redefinition, based on invisibility and, crucially, independent decision-making. Okay, let's start with a machine that our sources describe pretty chillingly, actually, as a metal ghost. We're talking about the Jian Sharp Sword.
Right. This is reportedly China's first fully autonomous stealth UCAV, that's unmanned combat aerial vehicle.
And when you say fully autonomous, you mean?
I mean, that phrase cannot be overstated here. This is not some glorified, larger hobby drone being flown remotely by a pilot sitting safely thousands of miles away. No, the Sharp Sword is engineered to be a completely independent fighter.
Independent? How?
Well, it's apparently capable of continuous flight for over 4 hours without any human intervention. That includes complex maneuvering, target selection, everything.
4 hours completely on its own.
Yeah.
And its design. It emphasizes survival through just not being seen.
Exactly. It uses this angular airframe, special radar-absorbing materials. The goal is to make it virtually invisible to current enemy radar systems. It's designed to be an asset that can penetrate airspace undetected, operate independently, and then strike with high precision.
So think about the strategic calculus this changes, right?
Right.
An autonomous system doesn't need to, phone home for every tactical move.
Precisely. Its onboard AI system identifies, tracks, and then destroys targets all on its own based on pre-programmed parameters. And it carries a substantial payload, 200 kilograms.
200 kilos.
Yeah, and it hits speeds up to 1,000 kilometers per hour. For reference, that's nearly the cruising speed of a modern commercial airliner.
Wow.
But this is a stealth weapon, completely unburdened by life support systems or the need for rest or anything like that.
That's speed and independence.
Yeah.
It's horrifyingly efficient, like you said.
Yeah.
But doesn't the autonomy itself raise questions? I mean, might it make decisions human pilots would veto? What about the risk of collateral damage or hitting a target a commander might suddenly see as strategically sensitive?
That's the critical friction point, isn't it, with all this tech? The developers apparently address this by limiting its initial operational scope. So it's designed mostly to hunt fixed or pre-identified targets, often deep behind enemy lines where the margin for error is maybe already considered high.
Okay, so controlled autonomy for now.
Right. But the core strategic insight is the scaling potential. Our sources note over 50 units have already been produced.
50 already.
Yeah, with plans to reach 200 units by 2026. This seems to signal an intention to replace large, expensive manned fighter wings with, well, swarms of autonomous, relatively disposable systems.
Disposable.
It dramatically lowers the financial and human risk threshold for initiating air superiority campaigns, makes it easier, potentially, to start something.
Okay. So if the Sharp Sword is the stealth fighter operating at high speed, the next platform, the Bluefish A3 bomber, takes this idea of a silent strike to a completely different level, almost surreal, you said, because of its propulsion.
That's where the noise, or rather the complete lack of it, becomes the story. The Bluefish A3 is described in our materials as a perfect aerial hunter, and it redefines aerial attack primarily because it uses a silent electric propulsion system.
Electric. So it flies in near total silence.
Pretty much. It eliminates that auditory signature that often betrays the presence of conventional jets, even stealthy ones, especially at low altitudes.
Which basically nullifies one of the most basic layers of defense, just hearing something coming.
Absolutely. This advanced acoustic stealth allows it to approach targets undetected by conventional radar and acoustic monitoring. Defense becomes significantly harder, and when you pair that silence with its targeting system, it's a devastating combination.
And it's firepower. You mentioned precision earlier. We're not talking big bombs here.
Exactly. It carries radar-guided air-to-ground missiles or laser-guided precision bombs, each weighing only 6 kilograms. Very small.
6 kilos.
Yeah, emphasizing surgical strikes over brute force. And just like the Sharp Sword, its operational independence is key. The Bluefish performs bombing missions, target ID, attack path planning, completely autonomously.
So you're essentially fighting in an enemy asset that strikes without noise, hits with pinpoint accuracy, and then just vanishes before you even know you've been hit.
It really does feel like fighting a ghost carrying a scalpel.
Okay, so those two platforms are focused on attack, the kinetic side. But the third piece of this air dominance puzzle, it provides the critical awareness, right? The monitoring, the surveillance aspect. This is the divine eagle, the all-seeing eye of the operation.
Right. The Divine Eagle is a strategic platform. It's not built for combat, but for persistence and depth of vision. It's physically massive, boasts a 15-meter wingspan.
15 meters. Wow.
And it's engineered for extreme altitude endurance. It flies up to 25,000 meters.
25,000 meters, that's incredibly high.
For over 10 consecutive hours. It's basically the highest, longest duration, unblinking eye they can put in the sky.
What makes its surveillance so revolutionary, though? What is actually seeing up there that, say, existing satellites or other spy planes can't?
Well, the key seems to be the integration of advanced quantum radar technology.
Quantum radar. Okay.
Without getting super technical, think of quantum radar as being able to potentially detect stealthy objects that conventional radar systems are specifically designed to miss. It might penetrate the invisibility offered by tech, like the Sharp Sword's stealth coating.
So it's designed to defeat the very stealth technology being deployed by its own side. That sounds like future-proofing its own surveillance against adversaries developing similar tech.
That's likely part of the internal strategic arms race, yes. But its immediate power comes from its whole sensor network. It doesn't just see, it processes data and builds real-time 3D maps of the entire battle space below.
Real-time 3D maps.
The sources specify it can track up to 500 individual targets simultaneously within a massive 600-unit range. Imagine it like a real-time Google Earth update happening every second across an entire theater of operations.
The strategic application of that kind of knowledge. Persistent, high altitude. It's staggering. Especially when you think about where China plans to deploy these.
Right. The plan is reportedly for 200 Divine Eagles to create an almost impenetrable monitoring barrier over the South China Sea by 2027.
200. And the cost?
Okay.
That must be enormous.
Well, this brings us back to the economics. Each Divine Eagle unit costs around $80 million.
Okay, $80 million is a lot. But
Contrast that with the multi-billion-dollar cost of a traditional aircraft carrier. Or a whole fleet of manned surveillance aircraft. Assets that are also, vulnerable to attack. You start to realize the immense strategic efficiency here.
Right.
China could achieve superior, persistent, high-altitude surveillance coverage over a massive maritime area at a tiny fraction of the cost. And with zero human crew risk, it fundamentally alters the cost-benefit analysis of projecting power in key strategic waterways.
So up high, the focus is cutting financial risk, maximizing self-independent recon. But down here on the ground, the focus seems to shift to eliminating human risk entirely.
Exactly. Transitioning from those invisible skies, we come down to the ground, where the reality of warfare is getting, even more intense. And maybe far stranger, ground forces have always been the most vulnerable part of any military operation, right?
Absolutely. The human cost is highest there.
But that vulnerability is now apparently being systematically replaced by tireless, fearless machines.
And this is where we see maybe the most visceral impact of this automation shift, starting with The direct replacement of the human soldier.
Enter the Agibot humanoid robots. Our sources pointedly describe them as disposable soldiers, which is, well, it's perhaps the most shocking term used in all this material.
Disposable soldiers.
These are humanoid machines built to match a human soldier's profile, 1.75 meters tall, 53 kilograms. But their capabilities are, well, superhuman in some ways.
Okay, let's focus on those capabilities. You said bipedal walking. That's key for rough terrain, places wheels or tracks can't go.
Definitely. And they can carry up to 80 kilograms of military gear, perform long-duration combat missions without any fatigue, rest, or needing food or water. They solve that fundamental human problem, physical exhaustion in a long fight.
But the detail that really jumps out, the one that makes you pause, like you said, is this concept of programmed sacrifice.
Yeah. Official statements apparently confirm these robots are designed and deployed with the specific purpose of acting as decoys to draw enemy fire, sacrificing themselves to locate enemy positions or protect human soldiers following behind them.
Programmed sacrifice. But wouldn't enemy forces pretty quickly learn to identify and just ignore those decoys? Is that just a sort of first-generation tactic that won't last?
That's the strategic calculus, isn't it?
Yeah.
Initially, yeah, maybe they force the enemy to expend expensive ammunition and reveal their positions, which is a win, tactically, regardless of the robot's fate.
Okay, fair point.
More importantly, though, it achieves the primary strategic goal, reducing human losses, particularly in those really high-casualty environments like dense urban warfare or highly contested areas like a potential Taiwan conflict scenario. The Agibot is seemingly intended to absorb the first, most dangerous wave of aggression.
It sends a profound signal, doesn't it, about the value placed on human life versus machine life within their military doctrine, prioritizing the machine's destruction over the soldier's safety in certain contexts?
It certainly seems that way, and the scale supports that intention. Over 1,000 units reportedly already produced.
1,000.
Yeah, with massive production increases planned by 2025. China seems to be rapidly incorporating automated martyrdom right into its tactical playbook.
Wow. Okay, so while the Agibots are designed for combat, for the front line, the logistics side, keeping them and any remaining human forces supplied, that's handled by a completely different kind of robotic beast, right? JSIC, the giant yak robot.
That's a fantastic contrast, isn't it? You've got the sleek combat humanoids, and then you have this massive bionic beast of burden, directly inspired by the Himalayan yak, known for its resilience. It's apparently the largest bionic military robot developed so far.
And its core feature is just getting stuff across impossible terrain.
Pretty much. JSIC is designed to solve that age-old military problem, getting heavy supplies across ground that stops conventional vehicles cold. It can carry a massive 160 kilograms of supplies and ammo.
160 kilos, that's significant.
At a steady 1 kilometers per hour, across virtually anything you can throw at it. Deep snow, scorching deserts, rocky mountain passes, viscous swamps. The source material states, quite unequivocally, nothing stops it.
And its autonomy is what makes it better than, say, a tracked vehicle in those places. It's not just following GPS, it's actually seeing the environment.
It's equipped with 12 sophisticated sensors. These allow it to process the environment almost like a seasoned, hyper-aware soldier would. It maintains incredible stability and flexibility while running, climbing, jumping over obstacles, navigating complex paths, all while keeping its heavy cargo completely stable.
So it removes human effort and risk from that dangerous supply chain part of things.
Exactly. Allowing human soldiers to focus purely on combat or specialized tasks, especially in those really remote, rugged border regions where Jack is apparently already deployed, getting heavy stuff to previously inaccessible areas.
Okay, so we have the combatants, the Agibots, and the supply mules, the JSHTAGs. But warfare is also about coordinated pressure, which brings us to swarm tactics, the Robo-Wolves and the RTG rolling robot.
Right. The Robo-Wolves are these quadrupedal units, like robotic dogs but built for war, designed specifically for urban and nighttime operations where their speed and silence are really maximized.
How fast are they?
Extremely fast, hitting 45 kilometers per hour. They're silent due to their design and heavily armed. We're talking 12.7 millimeter machine guns, grenade launchers, thermal vision.
But it's the tactics, you said, that really define their threat. They don't operate alone.
Crucially, no. They use organized swarm behavior, employing complex maneuvers like flanking, ambush, and yes, tactical unit sacrifice again, much like the humanoids, all to achieve larger objectives set by the overall command structure. They're designed to overwhelm defenses through coordinated automated pressure.
And they can keep going for a while.
Battery life is reportedly 12 hours, so they represent a sustained logistical and tactical nightmare for conventional forces, especially in dense urban environments.
Then you have the complete counterpoint, the RTG rolling robot. This 125-kilogram spherical fighting ball. It sounds bizarre,
Yeah.
and it's designed less for killing and more for control.
That's precisely its function, yeah. Though in a military context, it serves to secure areas without necessarily using lethal force. It rolls at an impressive 35 kilometers per hour.
35 for a rolling ball.
Yeah, and it operates equally well on all surfaces, sand, snow, even stairs. Maintains exceptional stability thanks to advanced internal gyroscopes. It's basically a mobile, armored containment unit.
What's its payload then? How does it actually control or subdue targets?
Its internal payload focuses on non-lethal tools. Things like tear gas canisters, powerful stun systems, surveillance cameras, and even nets designed for physical constraint.
Nets, okay.
This makes it an incredibly effective tool for control and subjugation. Say, in confrontations or riot situations where lethal force is undesirable or politically sensitive, it allows the military to project control while minimizing the risks that come with human interaction in volatile situations.
All right, let's shift focus now. We've talked about replacing humans, supporting humans. Now let's look at systems that actively enhance or protect the human soldier, blurring that line between man and machine and bringing us, firmly into classic military sci-fi territory.
We're moving beyond just protective gear here. We're talking full augmentation where the soldier effectively becomes an integrated weapons system.
Starting with the Norinco exoskeleton. This system isn't just a physical aid, right? The sources say it actively converts the soldier into an enhanced fighter, capable of feats that just defy normal human anatomy.
Just look at the performance metrics cited in the source material. They are genuinely shocking. The system apparently increases the soldier's weight-carrying capacity by a staggering 200 kilograms.
200 kilos extra.
It enables speeds up to 25 kilometers per hour for 6 consecutive hours, meaning a soldier can maintain a sustained, rapid pace faster than a marathon runner for hours, all while carrying hundreds of pounds of gear.
That's incredible.
They can reportedly jump over 3-meter walls, and get this, lift loads up to 500 kilograms.
Lift half a ton.
That's what the sources suggest. It's an exponential, almost unbelievable increase in physical human capability.
And the boost isn't just about raw strength, it's also about lethal efficiency, right?
Exactly. The system includes advanced targeting integration, supposedly increases the soldier's aiming accuracy by 300%, while simultaneously reducing weapon recoil to almost nothing. It turns a fit soldier into a highly stable, mechanized marksman.
And deployment. Is this just a concept?
The rapid deployment is what underscores its importance. 500 units reportedly already produced, with a target of equipping 5,000 elite soldiers by 2026. So this tech is moving rapidly from the lab into the field, at least for specialized units, making sure that the human soldiers who are deployed are the most optimized, powerful assets possible.
Okay, so if the exoskeleton enhances the physical soldier, the next system makes him disappear entirely. The stealth combat suits, using a mechanism that bends light around the body, achieving true, total invisibility. This sounds like pure fantasy.
It does sound like fantasy, but the sources treat it as a technical reality under development. The detail is complex, relies heavily on material science. The suit is apparently constructed using special materials composed of millions of microscopic structures.
Microstructure.
That actively control the passage of light waves. Think of it like, well, the classic analogy is looking through a glass of water. The object is still there, but the light is being redirected around it, making it seem transparent.
But how does it adapt? True invisibility needs constant environmental awareness, right? Changing light, different backgrounds.
It does. Before activation, the integrated system apparently scans the immediate area very rapidly, analyzes the lighting conditions, and instantaneously adjusts the material properties of the suit to perfectly match the background environment.
Instantaneously.
To ensure constant optical transparency. And crucially, the sources emphasize this concealment isn't just visual. It supposedly deceives thermal cameras, radar, and other known electromagnetic detection devices, too.
So completely undetectable by conventional means.
That seems to be the goal. A soldier in this suit would be totally isolated from normal military detection.
Combine an augmented super soldier with total invisibility. You've fundamentally changed infiltration, close combat, reconnaissance, everything.
Yeah.
Okay, now let's pivot. From personal concealment to massive defense. The ultimate defensive weapon. The LEI laser weapon.
Right. This brings us squarely into directed energy, a concept that's been theory for ages but now seems fully operational in this context. The LEI is described as a defensive laser system capable of downing hostile drones up to 2 kilometers away.
Downing them how fast?
In under 5 seconds. It shoots a focused, high-power light beam that basically melts or disables the target structure instantly.
You mentioned earlier the cost is near zero. If that's true, does that mean the whole defense doctrine against cheap drone swarms is instantly obsolete? Because that's a huge threat right now.
That is the core strategic point here. The operating cost is effectively near zero. It just needs electricity to charge the capacitors for the next shot. Now, contrast that with a single traditional interceptor missile, which can cost upwards of $100,000 per shot, easily. So imagine an enemy launches 1,000 cheap drones. Intercepting them with missiles could cost over $100 million. Intercepting them with the LEI laser costs, well, basically nothing beyond the initial system cost and the electricity bill.
That economic advantage is just staggering. It completely tilts the financial equation of air defense.
And the precision is equally important. Unlike traditional interceptors, which often use fragmentation warheads causing collateral damage,
Yeah, shrapnel everywhere.
the LEI laser apparently has surgical accuracy. It can destroy just the drone's engine or a critical flight surface without causing unnecessary collateral damage below. China has reportedly invested nearly $2 billion into this development.
$2 billion.
And 12 systems are apparently already deployed in strategic bases, each capable of firing 1,000 shots per day. This dramatically changes their air defense budget priorities and capabilities.
Okay, we've seen the autonomous Air Force, the tireless ground robots, the enhanced soldiers. Now we conclude with the systems that supposedly control them all. The highest level of autonomy, strategic decision-making, and silent naval power.
This is perhaps the most profound shift of all, conceptually. The potential replacement of the human general with, well, the digital commander. We're talking about a fully integrated, automated general staff.
China has developed what the source material identifies as the world's first AI military commander. And this isn't a simulation tool, you're saying. It's a digital general, developed in secret, managing and advising on real military operations, 204/7.
That's the claim. Its core function is apparently to formulate lethal tactics for both conventional and cyber warfare simultaneously. Crucially, the sources claim it makes independent strategic decisions after analyzing and supposedly surpassing the strategic patterns and long-term performance of veteran human generals.
Surpassing human generals, how?
It operates beyond human intuition, emotion, or cognitive bias. That's the theory.
How does it even develop its strategy? Where does its military knowledge base come from? Is it just data?
Well, its strength supposedly comes from integrating the strategy legacies of centuries of military thought, including revered historical Chinese figures like White General Peng and strategist Lin Biao. It processes their entire body of doctrine, battle outcomes, strategic successes.
So it learns from history.
And fuses that legacy knowledge with a massive, continuous stream of real-time data. From every sensor, every autonomous unit we've discussed today, satellites, drones, ground sensors, comms, intercepts, everything.
So it combines the, I guess, historic ruthlessness of human strategy with millisecond execution speed. That's a horrifying advantage in the heat of battle.
It creates a terrifying speed advantage that no human staff could ever hope to match.
Sure.
Think about the chaos of battle. Human minds falter under pressure, right?
Of course. Information overload, fear.
The AI commander supposedly operates with hyperintelligence, coordinating thousands of autonomous weapons, air assets, ground robots, cyber teams simultaneously, identifying enemy weaknesses and executing decisive, ruthless strikes in milliseconds. Human generals are constrained by the speed of their staff, their cognitive load, the need for sleep.
The AI has none of that.
None of those limitations. It truly is the digital general, if these reports are accurate.
And this hyperintelligence then feeds directly into automated firepower systems on the ground.
Right?
Like the Battery Animal artillery platform.
Exactly. Battery Animal is described as an automated artillery platform designed for endurance and precision. It can apparently operate for weeks without any human intervention, firing massive 120-millimeter shells up to 10 kilometers.
But the weapon itself is less important than the AI integration, you're saying?
Right. It's how it gets its targeting information and decides to fire. The AI fuses real-time data from every available source, satellites, drones, ground sensors, intercepted communications. It doesn't rely on preset coordinates called in by a human.
It finds its own targets based on live data.
It uses this fused multi-domain data to select the highest value targets autonomously. calculates the precise trajectory, chooses the optimal munition, maybe explosive, maybe incendiary, maybe even an EMP shell, and fires, all in less than 15 seconds from target identification.
15 seconds.
This is relentless, adaptive, automated pressure, continually refining and automating high-precision kill zones.
And the scale of deployment here. The sources indicate it's already significant. 200 systems deployed on the border with India.
That's what's reported, yes, with plans for hundreds more. Each unit capable of firing 50 rounds per hour, automating a continuous, potentially devastating barrage.
That kind of sustained, automated pressure, it frees up huge numbers of human personnel and removes the fatigue factor from one of the most physically demanding military tasks.
It represents a fundamental shift in how borders and forward positions might be defended or assaulted.
Okay, finally, let's turn to the sea, where stealth and autonomy have apparently converged to create the manta ray submarines. This sounds like another revolutionary impact, this time on silent naval warfare.
These aren't conventional submarines, according to the sources. Conventional subs are often betrayed by internal machinery noise, propeller cavitation.
The noise they make moving through what?
Exactly. These are described as underwater vehicles that mimic the actual movement of manta rays, which is a highly efficient form of silent biological propulsion. This design aims to eliminate the internal and external vibrations that inevitably reveal traditional submarines to hostile detection systems.
So the movement itself, based on biomimicry, makes them inherently stealthy. How does that affect detection?
Well, the integration of this highly advanced silent technology supposedly allows them to operate right next to enemy ships undetected by all currently known sonar devices.
Undetected by current sonar.
That's the claim. They could be invisible to the conventional tools used to hunt submarines, which is a massive tactical shift. Traditional naval superiority relies heavily on anti-submarine warfare, right? These manta rays could render that partially obsolete.
And their autonomy makes them a strategic nightmare, I assume?
They are reportedly fully autonomous, capable of remaining deep underwater for weeks without communication, waiting near enemy coastlines for months, potentially, ready to launch a destructive surprise attack on sea lanes or